2.2 graph of functions. So last time I started for graphing a function, we graph by using the plotting point, the function f of x equal x squared. So it was the graph for this function look like after by using the plotting point and the table. It was look like this. So this is the Cartesian plane. It has a graph like this. Then we graph the function f of x equal the function f of x equal x cubed. And the graph for this function is also look like this. And we talk about also the graph of function, the piecewise functions. The piecewise functions, like, by the way, this is the x-axis here. And this is x-axis. This is the y-axis here. And here also the y-axis. This is the function f of x. And here, let me change it. Instead of f, let me give it as g of x. So here is g. And this is the function is g of x. Okay. Now, also I talk about the piecewise functions, like function has two pieces. For example, the function f of x equal, this is two pieces. The first one is x squared with different domain. The domain here is x less than or equal 1. And the other function I talk about is 2x plus 1 when x is greater than 1. Okay. Also, I graph this function. So the graph for this function will be look like something like that. So here's the Cartesian plane. So first one is will be look like this at 1, 1. We graph it like that last time. This is x squared when x is less than 1. This is x squared when x is less than 1. So starting from 1, it is 1, 1. And the function 2x plus 1, it is a line. So the graph starting from x greater than 1. So at 1, give me like 3, but at 1 is not in the domain for the function, like I said last time. So it's going to be like open circle here. And this function here is 2x plus 1. Okay. So this is the 2x plus 1. This is x squared. Also, I give another example for the graph of the function f of x equal the absolute value for x. Here, x squared. Let me put it in this side. This is the function x squared. And this is x plus 1. Also, I was talking about the absolute value of the function f of x equal the absolute value for x. Since this is a piecewise function, this is mean it has a two different function with different domain. So the definition for the absolute value for x is x and minus x. X if x is greater than 0 or equal. Negative x when x is less than 0. And again, the graph for this function, let me remind you, by using the plotting point from last time and the table. We're not going to use the table again because we do it already in last time. So the graph for this function, it is something like this. Here, x, the graph for the function f of x equal x will be look like this. For the second one, minus x, it's going to be something like here, like this. So this is the minus x here. And the red one is the function f of x equal x. Again, this is the x-axis here. And this is the y-axis. Any question for these graphs? Anyone has a question? Okay, no questions, right? So here, minus x. Okay, today we're going to talk about how to see the graph is the graph satisfied to be a graph of function or is not satisfied to be a graph of function by using something is called the vertical line test. So the vertical line test is a test I can check is the graph satisfied to be a graph of function or is not satisfied to be a graph of function. So here, the vertical line test. Let me go to next slide. So this is the new things we're going to learn for today. It's called the vertical line test. So what is the definition for this one is, so suppose I have a curve. So here, the curve in the coordinate plane any curve in the coordinate plane. I want to check this curve is satisfied to be a graph of function or not. So the curve in the coordinate plane will be satisfied is a graph of a function if there is a condition, if only if no vertical line intersect the curve more than once. Okay, suppose I have a curve in the coordinate plane. I want to check this curve is satisfied to be a graph of function. I have to draw a vertical line. If this vertical line intersects the curve only one time, this means the curve is a graph of function. Let me give you example for this. What does that mean? Example. Suppose I have a graph. This is my coordinate plane. And this is also my coordinate plane. For the first one, suppose my graph look like this. For the second one, suppose my graph look like this. This is y-axis. This is x. And here is y. So this is a curve. Look, this is a curve. And also the blue one here is a curve. Now, to check this curve is a graph of function, I have to draw a vertical line by using the vertical line test. Then this line supposed to intersect the function at only one point. Look, if I'm moving in this red line, I see this line intersect the curve at only one point. Look, every time the line intersect the curve is only at one point intersect the curve. This means the graph of this function, this curve, is satisfied to be a graph of function. Okay? Makes sense? So I have a line, the red line. It's a vertical line. I'm moving this line on all the curve. I see this line intersect the curve at only one point. Because it's intersect the curve at only one point, this means this curve is satisfied to be a graph of function. So the first graph here.
What type of function you said it was?
Any function. This function here, it's like, look like this curve, it's a graph of function, but I don't know what the function is, but it's supposed to be a graph of function. Why? Because by using the vertical line test. I hope I answer your question. Any function, any curve, if I want to check any curve, I can using this test by using the vertical line. So here, this graph here, this here, this is a graph of function. This is a graph of function by using the vertical line test. For the second one, here, this is a graph of function. This is a graph of function for the second one.
No.
No, why? Because I have a vertical line here, the red one. I'm moving this vertical line on the graph. I see this vertical line intersect the curve at 2 points. This is the first point, and here is the second point. This is the first point. This is the second point. This is mean this graph, the blue one, the graph, the blue one, the curve, is not a graph of function. Why? By using the vertical line test. So here, because intersect the curve at 2 points, this means this is not a graph of a function. Any question? Any question? Okay, no questions. Let me give you another example. Okay, let me give you another example.
Okay.
Okay. Now, let me give you another example. So the example is, which is a graph, which of the following is a graph of function? So the first one is here. Second one third one, and the fourth one. Who will do the first one?
Me.
Yes. What's the answer?
That one isn't.
Is not, right?
No.
Why?
Because it intersects at 2 points. So it's not a graph.
Exactly. Nice. So look, by using the vertical line test here, the red one, look, the line intersects the curve, the blue one, at 2 points. This is mean is not a graph of function. So the circle, the equation of circle or any circle is not a graph, is not a function. Okay, so this is not graph of function. Second one, who will do the second one? This one?
That's the graph. I mean, that is a graph of function
Yes. Why?
because when you do the vertical line test, it only touches one.
Thank you, Mobin. Exactly.
point.
So by using the vertical line test, the red one, we see like every point, we see the line intersect the curve at only 1 point. So by using the vertical line test again, this is mean is not is a function. So this is a graph of function. Third one, who will do the third one?
The third one is a graph of a
Yes,
function.
as a graph. The same idea by using the vertical line test. The line intersects the curve at only one point. Look, this is mean it's a graph of function. So the curve here, this is a graph of function. The last one, who will do the last one? This one.
It's not.
It is not. Why? The same things. Draw a vertical line. Look, the line intersect the curve at one point, second point, third point, fourth point. 4 points intersect the curve. This is mean is not a function. And here the same things. So this is mean is not a function here. This is first point, second point, third point, fourth point. This is not a graph of function. Okay, any question for this example? So now we have to know which curve represents a function and which curve does not represent a function by using the vertical line test. Now let me give you another example, but this example without using the vertical line test. Here. Example, sorry. Which equations represent a function? By the way, what is the meaning of function? What's the definition of function? What is the definition of function? Okay, let me remind you. So in general, function, like a machine, every input has only one output. Okay. So here I give you like shortly is a rule. We know it's a rule such that every input has only one output. So every input has only one output. This is a function. Now the example is, so which equation represents a function? So the example is, the first equation is y minus x squared equal to, and the second one b is x squared plus y squared equal 4. Okay. So the first one I have to check is every input has only one output. To do that, we have to solve in terms of y. I mean, to solve in terms of y, I have to make the y equal. I have to make the equation y equal. Then I have to check is every input has only one output. Okay, so I'm going to do the first one, and the second one I give you like I'll choose one of you to do it. So the first one I have is 1y minus x squared equal 2. So first of all, I have to solve this one in terms of y, means I have to make the equation y equal something. So to make this equation y equal something, I have to add x squared for both sides. I get x squared plus 2. Now I'm looking for this equation. I see every input has one output, y. If I plug the 1 inside the function, 1 squared plus 2, they give me 3. If I plug 0, 2, I mean 2 squared, 4 plus 2, 6. And the same things for all positive numbers. And for 0, if I plug the 0, they give me 0 squared 0 plus 2, they give me 2. They give me one output. And the same things for the negative numbers. If I plug the negative numbers, for example, negative 1. Negative 1 squared is give me 1, plus 2 is give me 3. And negative 2, they give me 4 plus 2, 6. So the same things for all negative numbers. So now, look, every input has only one output, 3. The 2, they give me 6 only. The minus 1, they give me one output, 3. They did not give me 3, 4, 6, 7, whatever. They give me only 3, one number. The minus 2, the same things, they give me 6. The 0, they give me 2. This is mean this equation is satisfied to be a function. Okay? So this is a graph. This is represent a function. This equation represent a function. Anyone has a question for the first one? Is it clear how to think? Is the equation represent a function or not? Do you have questions?
Is there an easier way to know, like,
This is
mentally wise?
This is the easiest way. You have to solve the equation in terms of x, in terms of y, then you have to check, plug positive numbers, the 0 and the negative numbers. And you check, they give me one output or two output. Because they give me one output for every element, I plug it. So this is a function. Make sense?
Can you give another example?
For B, we're going to do B.
All right.
Okay? Who do B? Who will help me for doing B? So the equation is x squared plus y squared equal 4. First of all, we have to solve this one in terms of y. This is mean I have to make the equation y equal something. How we can doing this one to make it y equal something? So first of all, I have to subtract x squared from both sides, right? So then I get y squared equal 4 minus x squared. This is the first step. Now, here I have y squared. This is mean I have to take the square root for both sides. So when I take the square root for both sides, I get y equal what? Square root of 4 minus x squared. But don't forget positive, negative. Because when we take the square root in the equation, I have to take the two signs for the radical, the positive and the negative one. Now this equation, if we look into this equation, after we plug in numbers, like for example, 0, 1, 2, 3, minus 1, minus 2, they will give me two options, the positive and the negative. This is mean this equation not represent a function. Okay, this equation does not represent a function. Why? Again, because I have positive, negative. When I plug the number, they give me two output. First output is the positive square root of 4 minus x squared. And the second output is negative square root of 4 minus x squared.
I have a question.
What's your question?
For B, right? In the middle, where you have y squared equals 4 minus, yeah, there. How do you get from there to the bottom? Like you divided it just by the squared root?
No, I subtract x here. Okay, let me do this step by step.
I understand the first part,
First,
where you subtract the minus x, but then
okay.
afterwards,
Then I take the square root for both sides. So when I take square root of y squared, they give me y, but in this side they give me positive negative square root. Why? Because this is an equation. And also, before I said, the square root of y squared is the absolute value for y. And the absolute value, they give me two signs, the positive and the negative. Makes sense?
somewhat.
Yeah. So when you take the radical square root for y squared, I cannot cancel the square with that. I have to put, especially in equation, I have to put the two signs, the positive and the negative, as output. So this is mean here I get every input, two output. The first output is the positive and the negative. The second output is the negative. This mean is not represent a function. Okay, by this example, we end this section 2.2. Okay. Now let me show you some graphs. This graphs, we're going to use it during this semester. Here. Do you see the graph, the picture? Do you see the picture?
Yeah, we can see it.
Okay, perfect. So here, the first one, f of x equal mx plus b. This is a linear function. So the linear function always look like a line. Horizontal line, if f of x equal b, like f of x equal number 0, f of x equal 1, f of x equal 2, be like a horizontal line. Why? Because the slope is 0. For the second one, it has a slope. If the slope is positive, I said before, it will be look like this. If it's the slope negative, look like this side. For the second one, the power function f of x equal x to the n. If n is 2, square root, I mean like n, the power n equal 2, give me f of x equal x squared. So f of x equal x squared, it's look like a parabola, like in the picture here. Now for the f of x equal x cube, the graph for this function look like this. Same things for x to the power 4 and x to the power 5. Now the root function of x equal nth root of x. If the n is 2, so the square root, the graph for square root will look like this. If n is 3, the third root, the graph will look like this. And the same things for 4 and 5. Look, the even root, all the graphs are similar to each other. This is here, the root is 2. And here the root is 4. Look at the graph for the first one and the third one, similar to each other. And for the second one, if the root is odd, look, third root for x. It's similar to the fifth root of x. Now for reciprocal function, we're not going to use it a lot for the reciprocal function, but you have to know the graph for f of x equal 1 over x, the graph for this function, and also for this function, 1 over x squared. Now the last one, the absolute value, we graph it by plotting point from last time and this time too. The graph will look like this, the red one. Okay. Any question for these graphs? So you have to know how to graph each of these graphs, because next sections we're going to use it as a default graphs. We're not going to using the plotting point. So when I told you graph the function of x equals x squared, you have to know the graph, it will be look like this. And the same things for the other graphs. Okay, so now 2.3. Two 0.3. So getting information from the graph of a function. So now by looking to the graph of function, I can get any information from the graph. So let me start for this section by giving example. So, and I have the graph of the function look like this. Suppose I have graph. Okay. Here's 1, 3, 4, 5, and here's 6, 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. First point here. Okay. So, and here I have another point. Here is 35. Okay. Okay. So suppose my curve look like this. Goes up. Okay, this is the curve. This is the graph of the function. I need it. Now the question is, the first question, by using the graph, number 1, find f of 1, comma, f of 3, comma, f of 5. Number 2, which is larger, f of 1 or f of 5. Number 3, find the values of x for which f of x is equal 25. Number 4, find the values of x for which f of x is greater than 25. Number 5, find the net change from 1 to 3. Okay, who will do the first one? Find f of 1, f of 3, f of 5 by using the graph here. This is f of x. Who will do the first one? F of 1. What is f of 1?
25.
25. How you, okay. So she said 25. So you're going to the one in the x-axis and you go up such that when the curve, when the one is intersect, go up to the curve, then you see what's the value for the y, value for the x. Here we look on when we go up the one, see the value for 1 is 25. This is true. So the value for f of 1, first one here, f of 1 equal 25. Second one, f of 3. What is f of 3?
30.
30. So the same things, we go up in the 3. See when this point intersect the curve, so intersect the curve at this point at 30. So f of 3 is equal 30. What about f of 5?
Twenty.
20. Let's redo it. So again, go up here. Yes, it is look like 20. So again, f of, so f of 5 is 20. Thank you, Mobin. Now, for the second one, which is the larger, f of 1 or f of 5? F of 1 or f of 5? So to do the second one, we have to find the value for f of 1 and the value for f of 5. So from the first question, f of 1 is 25 and f of 5 is 20. So who's the larger? 25 or 20?
25.
25. So for the second one, which is the larger, f1 or f of 5? Since f of 1 is 25 and f of 5 is 20, so is it greater than f of 5 because f of 5 is 20. So the larger is f of 1. The larger is f1. Any question for the first first and second one example? Anyone has any questions? I get a question here. There is no plot for 5, only for 6. No, we have for 5. The same idea. You have to draw a line or like point and check where is this point intersect the curve. So intersect the curve at this point, then you have to check what is the y value. The y value looks like 20. Asrar. Okay. Now, find the value of x for which f of x equal 25. So here means they give me the y value is 25. Now they ask for the x value. For the third one, they ask for the x value. For x value, such that the y value is 25. How can I think for this one?
You can check which points go to 25.
Yes, exactly. Nice, thank you. So I have to check which point of this they give me value 25. So if I go to the one, yes, they give me 25. For two, it's not give me 25, they give me 35. For three, they give me something 30. For four, they give me, yes, 25. For five, they give me 20. For six, they give me, I think, 15. But I give you the easiest way. The easiest way when you get a question like that, find the value for x, draw a horizontal line at the point 25, like this. Let me choose different color. I'm going to use the green color. When they ask what's the value for x for which f of x is 25, the easiest way to think, draw a horizontal line at 25 and check which point intersect the curve at 25. So here I see the curve intersect the horizontal line at this point and at this point. This is mean third one here, number 3, the value of x are x equal 1 and x equal, this is 1 here because 1 intersect with a curve, the horizontal line, and x equal 4, 2. Makes sense? Now, number 4, find the values for x for which f of x is greater than 25. Same idea. You have to draw a horizontal line and check where is which point, which x values, such that the x values has y value is greater than 25. Which x value has y value greater than 25. Same idea, you have to draw a horizontal line. We check which point has a value above the horizontal line. As we see in the picture, number 2 has a value is above the horizontal line. Number 3 has a value above the horizontal line. Number 4, the same things. And also 250, 2.5 here in the middle has a value is greater than 25. So the solution for the number 4, you can set all the values starting from 1 until 4, like for example 1.1, it has a value is greater than 25. And the same, all the values here has a value greater than 25. So the solution here, the x values is the open interval from 1 to 4. Make sense? the x values are from 1 to 4, open interval. Is it clear? Again, you draw a horizontal line. Then after you draw a horizontal line, you check which value of x. They give me y value above this horizontal line. As we see here in this graph, number 2, they give me a value above the horizontal line. 3, the same things. 4, they give me the value on the horizontal line, but we don't need it because here they ask for any value is greater than 25 without the equal. If they ask with the equal, number 4 is a point inside the interval. So we put it a closed interval. So we keep it open interval because we don't have equal here. Make sense? Now number 5, who will do the last one? Number 5. What is the formula for net change? What is the formula for the net change? Do you remember the formula for net change from first lecture?
It's FB minus FA.
Nice. Yes. So let me remind you. Thank you, Mobin. So the net change for the function f from the point, for example, A to the point B is given as is f of B minus f of A. Again, net change is given as the formula f of B minus f of A. Now go back to the question, the example. Find the net change from 1 to 3. Number 5, the net change from 1 to 3. So you're applying the same formula here. What is the net change now? What is the formula? Who will do it?
F3 minus F1.
Yes, exactly. So f of 3 minus f of 1. Now, f of 3, you can find it from the graph, and f of 1, the same things from the graph. Or from the first example, because here in the first example, in the first question, the example, find f of 1 and find f of 3. F of 1 is 25, f of 3 is 30. So this is mean 30 minus 25. F of 3 is 30 minus 25. And the answer is 5. Okay, any question for this example? It's clear? Okay, let's now go into the domain and range from the graph. So now we can find the domain and the range from the graph will be easier by expecting what is the domain and what is the range. So the domain and range. So suppose my graph look like this. Here, this is my graph. This is the graph f of x. This is the x value, the x-axis. Here's y-axis. So now from the graph, I can find the domain and the range. So the domain, it will be like the x value, which is uses for the function. So the x value starting from this point here until this point. So all these values, the x values, is the domain for this function. So this is the domain. So the domain is the closed interval. Suppose this is A, this is B, closed interval from A, comma B. So now from the graph, will be easy to find the domain and the range. And the range is the y values, which is used for the graph. So the y value for this value for A, they give me is here. And the y value here for this point is like close to be here. So all these values is the range for the function f of x. Suppose this is C, this is D, your range, close interval from C, comma D. Any question? How to find the domain and the range from the graph? You have to check which x value are used and which y value are used for the function, for the curve in the Cartesian plane. Let me give you example for this. So this example from the graph. Find the domain from the graph, find the domain and range of the graph of find the domain and the range from the graph. So the graph, it will look like this, something like that. This is the y-axis, this is the x-axis, and the graph like this. half circle. So what is the domain or what is the range? Suppose this point here, this is -2, and this point here is 2. Suppose this point here is 2. Why? Because the radius is the same, 2, 2, -2. Now, who will give me the domain for this function? What is the domain?
-2 and 2.
-2 to 2. Is open interval or a closed interval?
Closed.
Close. Thank you. So again, you ask yourself, which value are used? Which x value are used to graph the function? Starting from this point, I use it because the value here suppose this function is f of x. F of -2 is 0, and all these points are used because f of 0 here is 2, and the same things for any point here. So all these points are used up to here. So this is the domain. Domain is the closed interval from -2 to 2. Now, what's the range for this function?
0 to 2, closed interval.
Exactly. From here, the 0 is used for the y, and all this point is used up to here because f of 2 is 0. Any point here, f of, for example, half, they give me a point here. Here, this point is used. So all the y value here are used. So the range is from the 0 is a closed interval up to 2. Any questions? Okay. So this is the domain and the range from the graph. Now, something new is solving equation and inequality by using the graph. Now we're going to learn how to solve an equation and inequality by using the graph. So let me give you the definition first of all, then by explaining the definition, I'm going to give you example. Here, solving equations and inequalities. Graphically. So the definition is here. Okay, let me read the definition. The solutions of the equation f of x equal g of x. Suppose I have two functions. First function is f of x. Second function is g of x. Okay. So the solution, to find the solution of two curves, suppose I have two curves, curve for f and curve for G. And I need the solution when f of x equal g of x. The solution are the values of x where the graph of f and g are intersect. So we're looking for the both curve. When this curve are intersect, I can find the x. So I'm looking for the x values such that the both of the function are intersect. For the second one, the solution of the inequality, if I'm looking for inequality of x less than g of x, are the values of x where the graph of g is higher than the graph of f. I'm looking for the value where the g function is above of the graph of the second function f. Okay, so now let me explain that by example. Suppose I have two curves. This is the xy Cartesian here. Okay, and the second curve is like this. Same things. The first function is g of x. So suppose g of x look like this. Function like that. This is g of x. And my second function is f of x. Suppose my f of x look like this. Function like that. Okay. Now, for the first one, the solution of the equation f of x equal g of x are the value for x. So we look into the value for x. We're looking for the value for x where the graph of the both function are intersect. So the both function, the blue one and the pink one, are intersect at this point, and at this point. So suppose this point here, this is A, and here is B. So the both function are intersect at this point and this point. This means the point x equal A and the point x equal B is the solution for f x equal g of x. I hope it makes sense. Any question for the first one? So the solution here, if the question asks what's the solution for f of x equal g of x, is the x value such that the intersect between the both function. Solution for f of x equal g of x are x equal A and x equal B. Makes sense? Any question for the first one? How to find the solution? for both function are equal? You're looking for the intersect. Then you're looking for the x values. Okay? Now for the second function, it's similar, exactly the same function. This is my g of x here. G of x. And the second one is f of x, green color. Make it more nicer. Like this. This is f of x. And now the question is, find the solution when f of x is less than g of x. Find solution when the solution for f of x less than g of x. So how to find the solution for this inequality? By going back to the properties, says are the values of x where the graph of g is higher than the graph of f. So we're looking for the graph of g is higher than the graph of f. Look to the curve. Here the graph of g is less than the graph of f because it's in the below, it's below the blue color, the blue curve is below the green curve. But if we start from this point here, we see the blue curve is above of the green curve. Starting from this point up to this point. All this point, the blue curve is above of the green curve. This means the solution of the set of solution for the second one, the inequality, starting from this point is A until this point, this is B. So suppose this point here is A, this is A, and this is B. So the solution is the open interval, because we don't have equal, from A until B is open interval. Any question? Makes sense? If you have any question, you can ask. I can explain more. Okay, let me give you a fast review again. If we're looking for the solution for the f of x equal g of x, we're looking for the intersect between these two curves. Where is the intersect? The first intersect this point, so the solution is x equal a. The second intersect this point is x equal b. For the second one, when the question asks what's the solution when the curve g of x is greater than f of x, we're looking to the two curve. We're looking which curve is up of the second curve. So here, if we look at the blue one, I see the blue curve is up of the green curve, starting from this point up to this point. But before this point, I see the blue curve is below the green curve. So this is not my solution. So my solution is starting from this point up to this point. And because we don't have equal, so we put it as open interval from A to B. Okay, now let me give you example. This is like explanation for the definition. Now example. Solve the given equation. First one, x squared equal x plus 2 by using the graph. Number 2, x squared less than x plus 2. Number 3, x squared is greater than x plus 2. First of all, we know the graph of this function, and we know the graph of this function by using the first section, the plotting point. So by using the plotting point, go back to the table and do the plotting point. I give you the graph of this function. It's a parabola. So the parabola here, x squared. So the graph for x squared look like this. No, it's not nice. Something like that. And the second one, x plus 2, it's a line because the slope here is positive. So the line look like this. You can use different color, like this. Oh, again, the red one is look like this, parabola. And both of these two functions are intersect at this point. And this point. And these 2 points are given. This point is -1. And this point is given 2 is 2. Who will do the first one and second one and third one? Who will do the first one? What is the solution for x squared equal x plus 2? So this is x squared, the red one, and the blue one is x plus 2. Who will do the first one? Again, let me remind you. Two functions are equal. The solution is the x value where the two graphs are intersect. Where is the two graphs are intersect? Where is the intersect between two graphs? Yes, -1 and 2. Thank you. The intersect at this point and this point. This is mean x squared equal x plus 2. The solution is x equal -1 and x equal 2. This is the solution for the first one. Now for the second one. They ask when x squared is less than x plus 2. When the graph x plus 2 is above of the graph x squared. When the graph of x plus 2, the line, is above of the second graph, x squared. So the blue one is above of the red one, starting from this point, -1. Look, from -1, the blue curve is above of the red curve, starting from -1 up to 2. In all these values, the blue curve is above of the red curve. So for the second one is the open interval from -1 up to 2. From this point up to 2 until 2. And open interval because we don't have equal. Third one, when the curve x square, the red curve is above of the second curve, x plus 2. When this curve is above of the second curve, x plus 2. When the red curve is above the blue curve. When the red curve is above of the blue curve, which interval? Shows here. The red curve is above of the blue one, and here too. The red is above of the blue one, but here not above, is below. So the solution will be all the values come from here, minus infinity, until -1, and also from 2 to infinity. So the solution for the third one is from minus infinity until -1, and from 2 to infinity.
You wouldn't write that as a union, you would put and.
Yes, union. Thank you. So here union. So from minus infinity to -1, all these values, -1 here, and from 2 to infinity. The 2 in the interval, open interval, it's the x-axis. The 2 here come from the x-axis. We're looking for the x values. The solution always the x values. This is coming from the x-axis. This is open interval, this is x-axis. Same things here. Okay, any question? How to solve inequality and equation by using the graph? Okay. 7 minutes left. Let me give you just the definition for increasing and decreasing function. And next time we will go over the definition, I explain and give you example. So now, increasing and decreasing function. So the definition for increasing and decreasing is given as here. And let me graph the function. So f is increasing on an interval I have interval I, if the f of x1 is less than f of x2, whenever x1 is less than x2 in the interval I. And the same things for decreasing. I know this is the definition and hard to understand it, But by graphing, I will explain more. Or I have to graph the both of them, and next time I'll explain more. I give you just general idea what's the increasing and the decreasing. So the first function, first Cartesian plane here. Suppose my graph look like this, and for the second one, suppose my graph look like this. So what's the definition says? F is increasing on the interval I. Suppose my interval starts from this point up to this point. If f of x1 is less than f of x2, whenever x1 is less than x2 in interval I, then the function f is increasing. This function is increasing. Why? Because x1 here, suppose this is my x1 and this is my x2. Since x1 here is less than x2, and x1 has f of x, it is here, f of x1, and x2 has f of x2 is here. Since also again f of x2 is greater than f of x1, this means the function is increasing. Again, if x2 is greater than x1, and in the same time x2 is greater than x1, and on the same time f of x2 is greater than f of x1, this means the function is increasing. But here is the opposite. This is x1, this is x2, f of x1, f of x2. Here x1, x2 I mean, is less than x1, but f of x2 is greater than f of x1. This is mean the function is decreasing, because x2 is less than x1, but look, f of x2 is greater than f of x1. This means the function is decreasing. So this is the general idea for decreasing, and this is the general idea for increasing. x2 is greater than x1, and at the same time f of x2 is greater than f of x1. So here increasing, here decreasing. Okay, any questions so far? So I'm going to stop up to here for today, and I see you Thursday.